Unit 9 is going to be just kind of some miscellaneous trick things. They didn't really fit in any of the other units, so they're just kind of random here at the very end of all our trig stuff. And the first thing we're starting with is lesson 9.1, talking about radians, radius, and arc length. We actually did some of this in geometry, but it still shows up a lot maybe on the ACT, so we need to go over it. Number 1, it says in a circle with the radius of 2 and an angle measuring 5 pi over 4 radians intercepts an arc. Find the length of the arc in simplest form. So first we need to know, what the heck is an arc? Well, an arc is saying, okay, we have a circle, we have a center point, we have a radius, which is from the center to any point on the outside of the circle, so technically this is a radius as well. And the arc is formed, it's the part of the outside of the circle that's formed by these two radii. So this is the arc length here. So it's actually part of circumference. Circumference is all the way around the circle, kind of like the perimeter of the circle. That's what arc length is. So we have this formula here, and once you know the formula, then all these problems become really easy. They use the letter S, don't ask me why, for the arc length. So that's like saying this is 10 feet or 2.5 inches, whatever this linear distance of the arc is. Like I take a string and stretch it out. And then R, of course, would be the radius measurement. And this is very important. This symbol we know is theta. That represents the angle. And I guess I should say central angle. That was a term we learned in geometry. A central angle is the angle that's formed by these two rays here. So that's called the central angle. What you need to know is that it's always in radians. So we'll get to some where either they give us degrees or they want the answer in degrees, so we'll have to do that conversion to get it into radians. So that's very important to remember. All right, so number 1, let's look at it again. We know our radius is 2. We know our angle measure is 5 pi over 4 radians, so that's our theta. Didn't realize my pen is going out. And then we are trying to find the length of the arc. So my formula will be S equals 2 times 5 pi over 4. It just wants it in simplest form. It doesn't say to round, so it's actually wanting us to keep pi in our answer. I'm going to cross simplify here. I'm going to divide out of 2, so it'd become 1 and that'd become 2. So my arc length would be 5 pi over 2. Okay, if they wanted the decimal, of course, I would take 5 times pi on my calculator divided by 2, but they didn't ask for that. All right, number 2 says we've got a circle. The radius is 9/10. That's how you read that decimal. The angle, so our theta, is 8.9 radians. So even though it doesn't have pi with it, that's still a radian measure, and that's exactly what we said we needed, was the radians. We just can't have degrees when we go to plug it in. Okay, and then we're trying to find the length of the arc to the nearest tenth. So now we're gonna have to actually figure out the decimal. So we've got our arc length, S, would be 0.9 times 8.9. And I get 8.01. Nearest tenth, that would just be 8.0. And that would be in, nope, they don't give us a measurement. I didn't know if that was centimeters, inches, or whatever, but they didn't give us one. All right, number 3, in our circle, we have an angle measuring 2 pi over 3 radians, so that's good to go. The arc length is 2 pi. We're finding the radius. So I'm still going to use this formula, but things are going to get plugged in different places. So my arc length they're actually giving me is 2 pi. Okay, and then I don't know my radius. I'm trying to find it, times my angle measure, 2 pi over 3. And so if I'm trying to get r by itself, I would really divide away this, but we know instead of dividing a fraction, it's really better to just multiply by the reciprocal. Should be 3 over 2 pi. What happens is your pi's will cross cancel. Actually, my 2's cross cancel and get a 1. So 3 times 1 is 3. My radius is 3. And again, they don't give us a label. Number 4, in a circle with a radius of 7, an angle intercepts an arc of length this. Find the angle in radians in simplest form. Okay, so my arc length they're giving me, that is my 35 pi over 4. They're giving me my radius this time, but they're not giving me my angle. This, when I find the theta, that will be the angle in radians. Okay, so I'm going to divide by 7, or since this side's a fraction, I'm going to multiply by its reciprocal 1/7. It's its simplest form again, so we're going to leave the pi symbol out of my math here. I'm just going to know this is 1 times 35. I guess I don't need a calculator. That would be 35 pi over 28. That's what the angle is. If they would have asked for it in degrees, I hope we remember that we would take it times 180 over pi. Because remember, pi is a semicircle, has 180 degrees in it, so you would cross cancel your pi. So really you're taking 35 times 180 divided by 28. That's equivalent to 225 degrees, but that's not what they wanted.